sharing the screen. It might be on a different screen.
Really? Let me try again.
Perfect.
I was saying it okay.
Oh, okay. Well, maybe it's just fine.
Can you see now?
Not yet. Now I see it. It says future of green,
Perfect.
immersion cooling.
Okay, good. So everything is set. That's perfect.
Awesome.
Okay.
Well, Jose, whenever you're ready.
Okay, perfect. So thank you everybody for coming. Thank you everybody for coming. Actually, as Sonia said, this is gonna be like some kind of course, some kind of webinar about where we see the future of green in immersion cooling technologies. So today we're gonna discuss not only immersion cooling but all the technologies in the liquid cooling. So this is gonna be the agenda. We're gonna give some kind of welcome, as Sonia said, some bit of overview about myself, Sonia as well. What is PTI? What is Submer? And so on. And then we're gonna discuss about some very short introduction of new era of data centers. What are the sustainability metrics? What is liquid cooling? And where is the future of data centers? As I discussed with Sonia and so on, I'm sick of this kind of trainings that they get very, very bored and so on. So we will try to make some questions to everybody, just to have an open discussion in here. So I guess it's gonna be more fruitful for everybody. So, as I said, welcome to this webinar. As I said, I'm a mechanical engineer. I have a master in climatization, HVAC, and also I started my whole career like 6 years ago in a HVAC company doing some kind of adiabatic cooling units, among other technologies. Since then, I've been planning most of the processes that a company can see, because actually I'm quite restless. And I've worked in operations, in engineering, and also in sales. So I started my path in sales like 4 years ago in Alfa Laval, selling different kind of, actually selling heat exchangers for the refrigeration market and HVAC market. Since then, I've dedicated my let's say professional life to dig a little bit more in data centers until here, when 2 years ago I joined Submer to discover this very awesome world, and to now give you this very short training. So if you're gonna introduce yourself, Sonia, or something.
Yeah, of course. Welcome, everyone. Hi, I'm Sonia Hugnew. I'm with Predictive Technology here in Omaha, Nebraska. We are a critical facility and critical infrastructure data center partner and reseller for a variety of products. Submer, we love working with, we're very excited about immersion cooling and what it can do for data centers. I'm on the business development side of the company. So we're just really excited to learn more about immersion cooling today. Jose, I'll let you kick it off.
Good. There we go. So I'm gonna give you a little bit of history. What is Submer? Actually, Submer was an idea in 2015, coming from Daniel Pop and Paul Valls. They wanted to make some kind of different data centers. They saw that there were massive problems in heating, and they thought, okay, let's do something different. So since then, they've been trying to create different kind of liquids to be used with servers and with no further issues. And finally, they touched the proper key. So they discovered some liquid, and since then they started to do different kind of, let's say, solutions for data centers with immersion cooling in general. So today, in Submer, we say that we are able to enable the next generation cooling and automatization for data center energy intense environments by integrating our pristine, high efficient, and sustainable technologies. And we can solve some challenges that today are very huge issues, as we're gonna see. So new era of data centers. Why data centers are so important nowadays? So if you look at the chart, this demand of data is growing every year. It's growing and growing and growing every year, and we expect to reach around 20% of the whole electricity demand going directly to the data centers market. In 2020, which was 2 years ago, since it is, all this data consumption, the energy consumed by this data consumption was around 6% of the whole electricity production around the world, which means that it was even bigger than the whole consumption in India. And this is a serious problem. It's a very, very serious problem. Also, if you look at the kind of consumption in data centers or in the market in general, in Europe, due to some kind of agreements and law, we have a commitment to decrease the CO2 emissions by 2050 more than 50%. And so far, we are pretty far away from that commitment. So this is why we need to be focused, very, very focused in this kind of technologies, because this kind of agreements or this kind of bugs are coming in different layers, and data centers are in the scope 3. So by 2030, this scope 3 is going to be very, very, very serious, and we will be redesigning and redefining how the data centers are going to work since then on. Sorry. And it's not only Submer who is saying that this is enough. I mean, the air cooling technologies are not enough. We have some very huge players like Google, Netflix, or Facebook that also say the same. For example, Google now is using different kind of liquid technologies to cool down their servers in the most efficient way. Netflix is now, let's say, playing around with these kind of things as well, because they saw that they were not efficient. Air is not efficient for them, or for example, Facebook. So all the big players are now looking at immersion cooling or liquid cooling in general. So why? I mean, how can we say that a data center is efficient or not? Because this is quite important. We cannot say that a data center is not efficient because we think it's not operating properly. We need to measure, because if we don't measure, it's impossible to see that something is well or bad. So we have different sustainability metrics. So the main formulas nowadays are the PUE and DCIE. The PUE is the power usage effectiveness. This PUE is quite huge, is quite abroad, let's say, because it embraces almost everything in data center. So even the lighting is included in this metric. Or for example, also the fans from the servers. So this is why, due to the different kind of, let's say, estimation or different kind of opinions in this market, people is trying to not use anymore the PUE metric. And the DCEI, sorry, is basically the reverse of the PUE. And this gives us some kind of opinion about how efficient is the data center. The closer to one, the better always. So since, as I said, since the PUE is becoming kind of outdated and so on, we need to measure everything with all the formulas, like the CUE, the carbon usage effectiveness. This is quite important because actually it goes directly to the energy consumption, and not only to that, also the kind of cooling we are using, the kind of cooling or the kind of UPSs, how we, let's say, manufacture the servers, which kind of materials, if the racks are made of metal or plastic or are recycled. So this kind of CUE, this new metric, are becoming quite important nowadays in the new data centers. And also another important, very important metric is the WUE, because some of the technologies are so efficient in the market now, but they are consuming tons and tons of water. And this is not something good, because to produce that water, we use a lot of energy. So actually, it's something completely, let's say, it's not good at all. We can say that data center is consuming a very, very low energy, but on the other hand, we are wasting huge amounts and tons of water. And in the end, it's wasting energy as well. So why these new metrics are so important? Because, for example, if we pay attention to the PUE as well, again, sorry, when we consider the IT equipment, there's many components inside the IT, like, for example, the fans. Fans, when the server is performing at peak ratio, the fans could consume around 15-20% of the whole energy of the server. And 20% of the energy, it's a lot. And actually, that energy is considered in the below part of the equation. So we are, let's say, faking a little bit the numbers. So when some people in the market say that we are using, or they are achieving a PUE of 1.3 or 1.4 and so on, it's because they are not considering the consumption of the fans. And this is not fair at all. And here we have another very interesting chart, which says that the air is the limiting factor. Actually, we need to think that air, it's an environment, and the whole server is surrounded by this environment. If the environment is more efficient, the whole cooling technology is going to be more efficient. So if we change air for a liquid, which is going to be 10, 20 times more dissipator, let's say, than air, this is going to be 10 times more efficient. So this is why we are going to talk about liquid cooling in general, and then we're going to make difference between all the different technologies in liquid cooling. Because with liquid cooling, we can reduce up to a 45% the reduction in carbon emissions. Also, since the 6% of the current technology is used for data, and this means that 4% of the whole CO2 emissions in the world, around the world, are coming from this market. We expect that 20% of the electricity consumption by 2025 are going to come from this market as well. We need to think that this is something more than important, to take into account. We need to be green. We need to make things different. We need to be innovation. We need to improve. Here we have some numbers. So if we pay attention to this number, the 45% of reduction in carbon emissions, considering this number, we can reduce all these amounts of kilograms of tons of CO2 using a very, very, very nice technology, which is liquid cooling. So talking about liquid cooling, we have three main technologies: rear door heat exchanger, direct to chip, and immersion cooling. So why we say this is liquid cooling? What means liquid cooling is my question. So I don't know if some of you want to answer that question or not. So if you want to tell me why, so I'm more than happy to hear you. Or you know the answer, we call liquid cooling technologies to those technologies that brings water to the rack. So if we are bringing water to the rack very, very, very close to the servers, we can consider this is called liquid cooling technologies. But for me, liquid cooling is when we surround the server with the liquid, like for example with direct to chip or immersion cooling. Direct to chip, actually what we are doing is to bring the liquid, that dielectric liquid, to the chips, only to the chips, to the CPUs and the GPUs. And then we still cooling down the whole server with air. And with immersion cooling, we do something similar, but not, because we immerse the whole server in liquid. So the whole server is in touch with the fluid. So every single component is going to be surrounded by this liquid.
Hey, Jose, can you explain direct to chip a little bit more? I know immersion cooling, you put the whole server, it's like dunking your cell phone in water. But how really does the direct to chip work?
Sure. Actually, if we look at our direct to chip technology, our direct to chip server, we can see a lot of tubes, very, very, very small tubes inside the server. So actually, we are bringing that liquid only to the point that are going to be a huge, massive problem in the future, like for example, chips, or for example, some memories, or for example, some different elements. But the rest of the server needs to be cooled by air. So we will see also fans in those servers. So if we do some kind of balance on this kind of technology, we can see that the complexity of the solution is going to be quite high. It's going to be quite high because we have many pipes, many point of failures, and then the TCO is going to become a huge, massive issue for the customer. So this is when we talk about direct to chip technology, we talk about those kind of servers. But then at the end, we are going to use the same cooling technologies in the outside, right? Coolers, cooling towers, chillers, or whatever, because we are bringing that water to the rack. Does this reply to that question, Sonia?
Yeah, it makes more sense. I was trying to understand the difference, so I just wanted to make sure. But no, I appreciate the explanation.
Absolutely. I mean, the main difference between direct to chip and immersion cooling is with an immersion cooling technology, you will see the server completely surrounded by liquid. It's going to be completely soaked always. So if we go now to the immersion cooling technologies, we can see two different technologies, one phase and two phase. With one phase, the liquid always remains in the same status. It's gonna be always in liquid. I don't know why I said gas. This is a mistake. I'm so sorry. But the liquid stays always in the same state, which is liquid. And with two phase, the liquid changes its phase from gas to liquid all the time. So actually, we can say that with two phase, we are boiling the water or boiling the liquid. So we can have some advantages and also some issues because of that. Because we need to think that when we are boiling things, the efficiency of the heat dissipation is going to be so awesome, very, very, very massive. But then we can face issues like microcavitation, a very huge pressures inside the tank, or also some kind of difficulties when we need to condensate the liquid, because condensate or evaporate things is not something easy, I can promise. So here we have some kind of pros and cons for the different technologies. As I said, direct to chip or cold plate cooling, that is also another name. Also, it's up to the vendor. You know, the whole layout of the server is going to be up to the vendor. We need to stick to that kind of design. We cannot change it. It's impossible. Also requires air and liquid. So the complexity of the solution is going to be super high, super high. And then the TCO is going to be, let's say, a little bit worse than with the other technologies. But on the other hand, on the pros, it's super efficient. It's absolutely efficient because we are attacking directly to our main problems, the chips. Then we have the immersion cooling solutions like single phase immersion cooling, where it's easier and safer to handle because it's always in the same status. You are not going to breathe any kind of gas, any kind of toxic gas, because sometimes those kind of liquids, when they evaporate, those gases are toxic sometimes. So it's not safe at all. With immersion cooling one phase, you have no issues with this in that regard. Also, that decreases a lot the complexity of the solution because you don't need to take one server, even can be a server for air. You do some kind of retrofitting processes, and that's all. You can immerse the whole server. You reduce the TCO, you reduce the complexity, and also is super efficient. And on the other hand, we have the immersion cooling two-phase, which honestly is the most efficient way of cooling a server, but it has many issues. Like, for example, as I said before, could be toxic, could be quite toxic. It's going to be very expensive because the liquid that we need to use is very, very expensive. And on the other part, the complexity is not going to be let's say, it's not going to be easy peasy, let's say in that way, because you need to think about pressures, you need to think about condensation, you need to think about microcavitation, about operations in the data center, etc., etc. That are going to make this technology quite difficult to handle. So this is why in Submer, we have decided to use always immersion cooling one phase. I have a video just to show you how this can look like in a typical operation. I'm not sure if you can see the video properly, but this is one of the installations that we have with a customer. It's around 1 megawatt. And as you can see here, the layout of the facility is going to be completely different because we are bringing water to the rack between fingers. So all the servers are going to be completely immersed in this liquid, as you can see. So we can even save some parts, like for example, fans. In immersion cooling, we're not going to use any kind of fan in the server. So this is also another saving. We need to think about it because as I said before, if we consider the energy consumption for the fans in the peak performance, will be around 20%. And 20% of 1 megawatt, it's a lot. It's a lot.
Hey Jose, when you're talking about putting all the equipment into the immersion cooling, we're talking about efficiency and energy savings. Is there also an effect on the equipment in the immersion cooling? Do you see a longer lifespan for the equipment in the immersion cooling because it doesn't have the fans, it doesn't have some of the pressure of the heat? Is that a thing that has been seen?
Absolutely, absolutely. That's a very good question because, as you said, we need to do some changes in the server to immerse it in the liquid. Like for example, we are not going to use the fans anymore, so we can we can remove the fans. This is a huge saving, not only in energy consumption, also in raw materials. It's very huge saving, sorry, in raw materials for the suppliers. Also, we need to, let's say, install some kind of, let's say, very thin indium foil layers between the heatsinks and the chips, just to make sure that the contact between those parts are always perfect, always perfect. And also we need to apply some kind of spray, coating spray, to prevent the remove of the labels. But that's all. That's pretty much all. And you can use any kind of server. Actually, you can take a server from a typical data center, do those retrofitting processes, and you can immerse it in the tank. It's not rocket science. Nowadays, you can use almost every brand of server for immersion cooling. The main consideration we should have is about warranties. You know, it's a very hot topic and very difficult sometimes to open, but it's something that we need to open with those brands, because we work pretty close with many brands to get those warranties. So far, it's not easy anymore. 2 years ago was a very huge issue, but it's something to consider. It's something to consider. We work with the brands like Fujitsu, like Hypertech, like Dell, like almost every kind of brand. Does it reply your question, Sonia?
Yes, it does. So you're saying a lot of brands have changed their warranty. Did it previously say if you put it in immersion, it wouldn't cover? Have they changed, you're saying, to say that immersion cooling is allowed?
Yeah. And also we need to look at something very important. If we look at the layout of the servers, this layout is changing. This layout is changing. 3, 4, 5 years ago, the layout were considered for air, only for air. Now, those manufacturers are starting to change the layout according to immersion cooling technologies. So this means that they are thinking about us a little bit. Okay, so just to continue a little bit. So this is, for example, one of the typical configuration that we can face in liquid cooling. No, I mean, in immersion cooling, one phase or two phase mainly. So we can see the white area with different kind of racks. Now the racks are not going to be vertical, are going to be horizontal and completely filled in with liquid. This liquid normally is dielectric, and according to the technologies, we can see some kind of element called CDU, cooling distribution unit, that can be placed either in the container or in the outside. In this case, since this is a Submer solution, a Submer image, our CDUs are considered inside the tanks. But with other brands, you can see the CDUs installed in the outside. So this is up to the installer, up to the customer, or up to the solution. Because we, in Submer, we also can offer this CDU, external CDU. So you can see here, we have the temperature that we are going to work. The main difference between air and immersion cooling is the temperature, the working temperature of the servers. Because we can get higher temperatures, and then it means that they are going to become more efficient. Because working at 50 degrees, of temperature is not working at 27 degrees of temperature like in air cooling. So the efficiency mainly comes for the temperatures. And also something super important to mention is now, since the environment is changing, it's not air anymore, it's liquid, we can gather that energy much easier than before. So now we're going to open different windows about what to do with that energy, because we can even use this waste energy for other purposes. And we will comment this later, but this is something super important to bear in mind, because this is the main benefit of immersion cooling. Use the waste energy. And with some immersion cooling, we can face this kind of benefits. As I said before, with liquid cooling in general, you can face up to a 45% of carbon emissions. reduce it, sorry. The PUE can become around 1.03, which means a 90% of increasement in the efficiency of the data center. Also, we're going to decrease a lot the cooling. Well, as I said before, sorry, because of this PUE, we're going to achieve up to a 95% of benefit in the cooling OPEX. The density is going to be even up to 10 times more, since the space used with this technology is going to be smaller. We can reduce the capex of the solution. And some of the questions that Sonia made before, but I didn't answer because I was waiting for this slide, is about the hardware, about the lifespan of the hardware, about the failures. As we said before, we're not going to use fans. The dielectric liquid is 10 times more dielectric than air. That means that the hardware lifespan is going to increase at 30%, and the failures in the server in general is going to be up to a 60% lower. So we are going to use the same servers for more time with less failures. That means that the operations that we need to do in the data center are going to be reduced. So this is also another saving for the company. So where's the future of data centers? Where we see this future? Because we've been talking about all these benefits and so on, but when immersion cooling makes really sense. So as I said before, this is very, very important. We need to think that immersion cooling opens a very, very huge window, which is heat reuse. We can leverage this wasted energy. We can use it to heat up other buildings, or if the OEMs and servers allows us to work at 80 degrees, we can even generate energy. We can use different kind of combined cycle technologies or whatever. And all the manufacturers are thinking on this. They see the future of the technology, the future of the data centers as the solution for this huge gap lack of the resources, because we can even leverage this waste of energy to create more energy. And that means that we can achieve installations where we can achieve a PUE below 1, which means that we can create energy with data centers. If we create energy with data center, it means that this is not going to be never another pain point for the customer or for the society. It's going to be a very huge relief. So we can invest even more in data centers to improve the technologies and do better things bit by bit by the time. So for example, here we have some kind of different layouts or different installations. We can use different kind of technologies or units or whatever to reuse this heat. For example, with air, we can use cooling coil batteries and so on, but this is not very, very efficient. But with immersion cooling, this increases a lot, because as I said before, gather this energy in liquid is much easier than gather this energy in the air. But also, the future of data centers is not only with heat reuse. It's about to combine different technologies, because if we create hybrid configurations, we can find some kind of point in between where the air cooling is going to be more efficient, and the liquid cooling technology is gonna allow us to sell the waste or the energy don't really want in the data center. So we need to think about this, about how to combine all the technologies that we can face in the market to create this kind of hybrid configurations, to create these very nice installations called data centers, and create, as we say in Submer, create data center that makes sense. So I don't know if you have any kind of question, or do you want to open something, Sonia?
Yeah, we just had some points we wanted to bring up with everyone. So one of the big things we've been taught our whole life, electronics do not mesh well with water. We think of our cell phones even splash water on you. Oh no, it's now broken. So, is there any concern, anyone on the call, I know, Jose, we've got the technology, we've got the data, but there's always that inherent bias of, well, I'm not supposed to put things in water. Does anyone have any thoughts on, sticking a server in liquid?
Maybe not. Well, at least I can tell you my experience about put the hands on liquid, because it's kind of crazy. I can tell you, because if we think about electricity and so on, the solutions that we have in Submer are to dissipate 50 kilowatts of energy. 50 kilowatts of energy, it's just to give you a little bit of overground, is the thick of the cable is like this. So you can imagine how much energy is going through that cable. It's absolutely crazy. So if you touch the cable, you pay a visit to the hospital in a few seconds. With this kind of solutions, you avoid this kind of electrifying event. I'd say. This is because
oh, go ahead. Sorry.
Oh, sorry. This is because I was going to say that this is because the consistency of the liquid is denser. It is kind of denser. So it's like a baby oil when you touch the liquid and so on. According to the different liquids, you can see different roughness or different thickness or different even colors or whatever. But it's more or less like a baby oil.
And Jose, I know I've spoken to your team before, but is it true that it's actually human grade consumable?
Yeah,
not
actually,
that you'd be drinking it, but
actually, it depends on the liquid. I really need to aware you, because if you drink any kind of dielectric liquid, okay, could be very, very toxic, very, very toxic. So you need to pick the correct ones. For example, the Submer liquid is let's say is not good, but you can drink up that liquid. It's also very, very sustainable, because it's a 96% biodegradable. It's completely non-toxic, because it has a food grade certification. But without the electric liquid, take care.
Yeah, I don't think anyone will be diving in for that to put in their morning coffee, but it is very cool that
yeah, and actually the taste is very rough. Honestly, the taste is very, very rough. When you drink that liquid, it's like, oh, what I did. Why I did. Yeah.
Does anyone, now we've talked about a few other pieces. Does anyone have any other questions for Jose about, the actual application of immersion or liquid cooling, or, just some concerns maybe you've heard when you've started working in it or just started hearing about immersion?
I know some of the things that I've heard, just chime in here, this is Jeff with PTI, was about hard drives and everything else. And like Jose was saying, most of the new technology is using solid state drives and everything. You don't really have the RPM drives anymore, but you can still use those in the Submer, is my understanding, as long as you get the proper sealed drives and not just like the cheap standard ones you'd get from like, Best Buy or someplace like that.
Oh, yeah. Actually, with liquid cooling technologies, when you immerse the whole server, you need to make sure that the hard drivers are not there. You need to use solid state storage. Because with these hard drivers, you can face some issues, because it has inside of the hard driver, you have some kind of spinning media. So more or less, it's like with the fans. We remove the fans to prevent any kind of failure. So yes, you're right. You need to take some considerations like that to immerse a server.
Perfect. And does anyone have any other questions for Jose? Yeah, if not, we appreciate your time. Jose, thank you, because some of those stats are really, really remarkable. When you really think about, I think the biggest one that, I would love for the group just to take away from is think about a data center being able to save enough energy and use the energy they create to keep the lights on, to run the HVAC, to essentially supply power to their neighbor. So I think that, on top of the immersion, that's just such a cool benefit that could come from the immersion cooling and a wider use of it. So I just think that's fascinating. And, we appreciate everyone getting on the call today. We will send out the CEU certificates later today. So you'll be getting that showing that you attended and all the information you would need for your credit. And then if you have any other questions, just feel free to reach out to myself. You've got me on LinkedIn, or I've sent you the invite via calendar. So just reach out to us, and we're here to help answer your questions about immersion cooling, because predictive technology, we're just really excited about it as well. Perfect. Well, I appreciate everyone. Yeah, I appreciate everyone joining, and I hope everyone has a great day. Jose, thank you.
Thank you very much, Sonia. Thank you very, very much. And thank you everyone for coming.